Starting with number 4, which is a testing, just testing to see if these points are solutions. Okay, so they've given us 3, 2, and also -2, 1. So we're going to see, are these solutions? So we're going to put in this x and this y and see, is it true? Will this side be less or equal to, less than or equal to this side? So y is going to be 2, less than or equal to -5 times x. So is 2 less than or equal to -15? It's not less than or equal to this. This is bigger than this. So no, this is not a solution. We'll try this one now. Y is 1, less than or equal to -5 times x, which is -2. Is 1 less than or equal to -5 times -2 is +10? Yes, it is. So this one works. This one is a solution. So it's just a check, and that's what a solution is. It's something that makes this expression, it's not an expression, it's this inequality true. Is it true when you put these points in? And for the second one there, it is true. Now we'll go on to number 7, actually graphing some of these. X is less than 3, so this one we don't have a y at all, and so how do we graph this? Okay, so this goes back to graphing vertical and horizontal lines that we learned in a previous section. First, let's go to where x is equal to 3. Where is x equal to 3? Right over here. Here x is -3, x is +3 here, x is +10 over here. This is where x is 3. And x is going to be less than 3. Okay, so let's just think of this as a single number line like we have done before when we were first graphing simple inequalities. So if we're going to say x is less than 3, we would have put an open circle here, and we would have graphed this way, right? X needs to be less than 3. But now we're in not just 1 dimension, but 2 dimensions. So how do we show where we used to use an open circle? Now that we go to a line, how are we going to show that we're not going to include the values on this line as solutions? Well, instead of a solid line, we're going to use a dotted line. Okay. So this dotted line is telling us that the solutions will not be found on the line, but in other places it will be. So where are the values of x less than 3? Well, we already know that. It's to the left. Less than is to the left on the x axis. So there you go. Simple as that. And now let's go on to number 11. Alright, y-intercept, slope, it's just that easy. Okay, so y-intercept is going to be -1. Slope, we're going to go down 2 and to the right 1, or we could go up 2 and to the left 1. That's going to give us our line. There we go. So you just graph the line just like if this were an equal sign. And it is an equal sign. It's part equal sign, part less than sign. And since the equals is included, if these two sides are equal to each other, we would make this a solid line. Because the points on this line are solutions. Because if you pick this point here and you put in this x for this x and this y for this y, both sides will be the exact same, and that's just fine according to this bottom part of the symbol. Now we want to shade in some region on one side or the other of the line, and I want you to think above it or below it, above or below, because when you write it in slope-intercept form, that's the easiest way to think of it. when these lines are really close to vertical, you're going to start to think left or right, but always think above or below, above or below. Why is that? Because above or below is a vertical thing, and y is vertical. The y is a vertical thing. The y-axis is vertical. So now we can just say, where are the y's that are less than this thing which created this line? So where are the y's that are less than this line? Well, in the vertical arena, less than is below. These values below here are less than. Okay, so we should be able to shade in the y values that are below this line, and all these y values will be less than these y values being the ones that are on the line. Okay, if that's at all confusing, think of it this way. All the points in here, if I pull this point out, if I put in this x and this y, then we should get a y that's less than whatever this turns out to be. Okay, and by extension, everything that's over here should not be a solution. Everything over here should not work, or in other words, this side will come out to be bigger than this side. And a really easy point to test would be this 0, 0. If you can ever use 0, 0, you should, because it's really easy. Or if you can get one of the values to be 0, you should. So if we're right, if shading over here is correct, then this 0, 0, since it's on the other side of the line, since it's above the line, should not work. So let's try that. 0 should come out to be bigger, actually, than this side. -2 times 0 minus 1. 0 less than or equal to 0 minus 1, which is -1. And that's not true. 0 is bigger than -1. So that's not going to work. That's what we wanted. We wanted the 0, 0 to not work, and we can shade that region. If you're having trouble thinking above or below, you could just kind of go backwards. Test 0, 0. If it doesn't work, don't shade that side. Shade the other side. Okay? That's probably the more common way that you're instructed to do that, but to me, this is much more intuitive. The y values that are below this line are going to be less than the y values on this line. Okay, so either way you want to do it that way. Let's do another, number 15. So with number 15, we've added a little extra step of putting it into slope-intercept form. So subtract 2x from both sides. Y will be less than or equal to -2x plus 6. So now it's in slope-intercept form, and we can graph this line no problem. Okay, 1, 2, 3, 4, 5, 6 is the y-intercept. Go down 2 into the right 1. That's our slope. Okay. Now, when we go to graph this line, we want to say graphically what this is saying symbolically, that it's not okay if these two sides are equal. Now, if we were to draw a solid line, that would imply that all the points on that line would be solutions, and the points on that line would make both sides of this equal. So we want to say, don't include the points on this line, so we make it a dotted line rather than a solid line. And we're just saying, these guys on here, not going to work, because if you pick a point on the line, both sides will be equal, and there is no equals to sign, so that doesn't work. And then we say, well, where do we shade? Do we shade above or below? Well, we want this y value to be less than this, what you get out of this, and whatever you put in for x here is going to give you this y. It's going to give you points on this line. So the points that are below this line will make this y less than the values you get on the line. So less than would be below, greater than would be above. Let's test this theory with the point 0, 0. So I'm saying that since the y values that are below this line should be less than the y values on the line, 0, 0 should work. So 0 should be less than what we get on this side. Remember, when we put in 0 into this side of it, that's going to be the point that's on the line. So we should get a 6 here. So 0 should be less than negative 2 times 0, which is 0 plus 6. And yes, that is true. 0, 0 is a solution, and that can tell us that all the points underneath this line will also be solutions. Okay, this shading really represents that we're saying this point works, and so does this one, and this one, this one, this one. All of these ones work, and all of these ones. And if we just put all of these points down, if we possibly ever could, put down all these points all through here, it would create this solid filled-in space like that. Okay, so let's do another, number 18. 2x plus 5y is less than or equal to negative 10. 5y is less than or equal to negative 2x minus 10, just subtracting 2x from both sides. We want slope-intercept form, so we're going to divide by 5 on both sides. Okay, no need to flip that sign around. This is a positive 5, so that's fine. So we get negative 2/5 x minus 2. And now we can graph. So we're going to graph this just like we would a normal line. It is less than or equal to, so we're going to make it a solid line, not a dotted line. Negative 2 is the y-intercept. The slope is negative 2/5, so we'd go from our y-intercept. We go down 2 and to the right 5. So that would be our other point, and it will be solid, so I can go ahead and use this. And there's our line. And not only do we want to show solutions on the line, but either above or below, depending on what's going to come out to be correct. Maybe you've been following along really nicely, and it's really intuitive for you as well, and you know whether you should shade above it or below it. Maybe you don't like that, you like the other way, so let's just do it the other way. Since 0, 0 is not on the line, okay, that'd be the only time you couldn't use 0, 0 as a test point, because it would really be useless. We need something that's off the line to see, is this where the solution shaded area should be, or should this be down here? So we'll plug in 0, 0. 0 is less than or equal to negative 2/5 times 0 minus 2. Is this going to come out to be true? Let's see. Is 0 less than negative 2? No, it's not. So that doesn't work. This is not a solution, so this should not be shaded, so this should be down here. Okay. And if you think in the other way, this y value here needs to be less than this line here, and the y's that are less than would be below the line. If this were flipped around, it was greater than, it would be up here above, but it's not. Okay. And that will be all we're going to do. The other stuff is just, you know, slightly more complicated examples of this with fractions, but that should be fine, and absolute value, which we're not going to bother with. Okay, so thanks for watching.